Okay, so today we're going to look at some trig ratio problems that involve a couple of steps. So let's take a look at this example. So we're supposed to find the length of segment AD. Well, I'm noticing that there are two different triangles, one on the left, triangle ABC, and one on the right, triangle ADC. And obviously AD is part of triangle ADC, but I'm noticing I only know one piece of information in that triangle, and that's not enough. So I guess what I first need to do is focus on the left triangle. So let's focus on triangle A, B, C. So if I'm focused on that triangle, what I want to find, even though it wasn't asked, we weren't asked to find this, I'm going to need it to use in the other triangle. So I'm going to find the length of segment AC, and that's going to help me then to find AD in the other triangle. So let's go ahead and do that. So I'm looking for, we'll just call this X, segment AC's length, and I know if I'm using 50 degrees as the reference angle, I know that 27 is the hypotenuse and X is the opposite. So I'm going to be using the sine ratio, because sine is opposite divided by hypotenuse. So sine of 50 degrees is equal to opposite, which is X, divided by hypotenuse, which is 27. So I know to cross multiply that, 27 times the sine of 50 degrees is equal to X. So in the calculator, I'm now going to type 27 times the sine of 50 degrees. And when I do that, I'm getting X is approximately 20.68, and those are centimeters. So I'm going to go ahead and fill that in, 20.68. Now, again, that's not what I was looking for, but it's going to help me in the other triangle. So if I take a look at triangle ADC and I look at the 59-degree angle, X is still the opposite, but I know that now. It's 20.68 centimeters. And of that triangle, segment AD, the one I want, is the hypotenuse. So once again, I'm seeing opposite and hypotenuse, which means sine. So sine of 59 degrees is equal to opposite, which is 20.68, divided by hypotenuse. I'll just call that y. So cross multiplying y times sine of 59 degrees is equal to 20.68. So I know to solve that, I'm going to divide both sides by the sine of 59 degrees. And when I do that, I'm getting y is approximately, and of course I have to type that in the calculator, so 20.68 divided by the sine of 59 degrees gives me approximately 24.13, and these are centimeters. So that is what I was looking for, which is AD's length. Okay, so we had to go about that in a couple different steps before we could figure out the length of AD. Let's take a look at another example, another couple examples. So this time, again, I have a couple different triangles that I'm looking at, but I also was given some information, and I can see that these triangles are special right triangles. So let's focus on the one on the left here. So I'm seeing 45, 45, 45, 45, 90. So I'm going to go ahead and mark what I know, which is that this side is congruent to this side, and that this side is congruent to that side. So I also know that the ratio for a 45, 45, 90 is x, x, x times the square root of 2. So if I have the 90, if I have the hypotenuse in this triangle, I know uh, I know that that length of the hypotenuse is 6. So if I'm going backwards from the 90 to one of the legs, I have to divide by the square root of 2. So that means I'm going to take 6 and I'm going to divide it by the square root of 2 to get the leg lengths. Well, that's not simplified, so I'm going to multiply that by root 2 over root 2, which we did before, and I get 6 root 2 over 2, which I can simplify. 6 divided by 2 is 3, so I simplify that to 3 root 2. So that means that this is 3 root 2, and so is this one. Okay, both legs are 3 times the square root of 2. Now, that's not what I was supposed to find. I'm supposed to find x, which is up here in the other triangle, but that's going to help me to figure out what x is. So again, I'm going to my ratio x times the square root of 2, and I know the hypotenuse of that triangle is 3 times the square root of 2. So I'm going to take 3 times the square root of 2, and I'm going to divide it by the square root of 2, again because of this ratio here. And so I'm starting with the hypotenuse and I'm going backwards to the leg. So I'm dividing by the square root of 2. So the square root of 2 divided by the square root of 2 simplifies just to 3 times 1, which is just 3. So that means that x is 3, and actually so is this other leg here. So 3 equals x, and so I know that x is equal to 3 centimeters. Okay, let's take a look at this other triangle here. So here I see a 30 degrees marked and a 90 degree mark, which means this one is 60. And same thing here. And actually, I just realized there's a typo here. This should say 60 degrees up here. So this is a 60 degree angle, not a 30 degree angle. Okay, so that so this is 30, and that one's 60. Okay, so we're going to focus on this triangle here on the left-hand side first, and I'm remembering my 30, 60, 90 ratio, which says x times the square root of 3, and 2x. Of course, starting with the 30 degree angle, then the 60 degree angle, then last the 90 degree angle. So I know the hypotenuse, which means I know the 2x. So that's 8. So remember, we want to go back over to the 30 degree angle, or the side opposite that. So I divide 8 by 2 to get 4, and that'll take me to the side that is opposite from the 30 degree angle. So this is our 30 degree angle here, so I'm going to go opposite of that, and I know that 4 belongs there. Well, that was actually pretty helpful for me because now I figured out the side that the two triangles share. So, and I can see that that is the hypotenuse of that triangle on the right. So if 4 is the hypotenuse, again, I'm going to go backwards to get the 30 degree, the side opposite of the 30 degree, or the short leg, and divide 4 by 2, I get 2. So opposite of the 30, that is 2. Okay, and then opposite the 60, that is, I have to multiply that times the square root of 3, and I just realized we're missing our x as well. So this problem was a little messed up, but that's okay, you get the idea. So x was supposed to be this one. So I'm going to take 2 and I'm going to multiply it by the square root of 3, and that's because of my ratio, and that is the length of the side that is opposite of the 60 degree angle, which is this one right here. So x is that side, and the length is 2 times the square root of 3, and those are inches. So that is what I was looking for. And that's how we solve trig ratio problems that involve a couple of steps.